All right, so what is a moderator? This is the first video, other than the overview for week 5. And the moderator is really central to, obviously, moderated regression. But what I want to do is start out with the simplest way of explaining a moderator, which is generating data so you can see what a moderated effect looks like. So to begin, I'm going to run a simple model that is truly an additive model. So you can see here x1 and x2 are both random numbers that I generate a y from, and I actually generate the data. I generate y as a function of x1 and x2, and I add a random normal error. Okay, so this is what I get from my summary. Is I get a very simple model where I have a main effect, two main effects that are significant, and an interaction that's non-significant. So what does that mean? That means that y is a function of x1 or x2. And that's what this plus is. It just says that in my model, even though I have it modeled as x1 or x2 or x1 and x2. That's the way R works, is the asterisk is an expansion operator. So what it does is it allows me to model x1 or x2, and then it puts in the interaction. As you can see, the interaction is non-significant. Now, why is that? Because I modeled it purely as an additive model. But what happens if I model it as an additive model it meaning the criterion or the dependent variable? If I model the criterion as both a function of the additive effects of x1 and x2, as well as the interaction, what do we get from that? Well, I'm going to run this, and you'll see precisely what we get. What we get is a significant interaction now that we did not get before. Why do we get this? Well, because y is dependent both on, well, it's dependent on three pieces. It's dependent upon x1, or it's dependent upon x2, or it's dependent upon the combination of x1 and x2. And that's what the moderation is telling us. The moderation is telling us that x1 alone cannot help us predict y. x2 alone cannot help us predict y. It's the combination of x1 and x2 that's a significant predictor. Now, in social and behavioral sciences, typically what we would say is that if you have a significant interaction, that you ignore the main effects. Now, why is that? Well, it's because the interaction is telling us something very specific about our dependent variable. It's saying that the omission of either x1 or x2 does not tell the complete story of y. And the reason for that is that x1 and x2 combined are a significant predictor of y. So even if I modeled this and I chose not to include the interactions, the main effects at all, this is what I would get. I would get a significant interaction alone, and because I've modeled only the interaction and not the main effects, I would have a significant predictor. Now, what would happen if I, with this data, if I modeled only the additive effects? What would happen is it would be misleading. And the reason why it's misleading is it doesn't tell the total story that x1 and x2 are both important. Now, how do we get this? Well, if you take a look at the adjusted R squared, we account for 66% of the variance, which, as most of you realize, this is an unrealistic outcome. But if I look at my full model where I've included both the interaction and the main effects, that's up here. So I have both main effects and the interaction. You'll see I account for almost 3/4 of the variance, 74%, okay, for my adjusted R squared. That's pretty good. So that means that what am I leaving on the table? Well, I'm leaving about 9 or 10%, maybe more. Let's see, 66%, 74. Yeah, I'm leaving 8% of the variance in y on the table. But more importantly, it's the combination of the two. And if you look up here, that when I only model the interaction and the interaction alone, look at what my adjusted R squared is, 62%. So by modeling x1 and x2, I'm accounting for a lot of the variance in y. And you can see that right up here. This is how I constructed my y. I constructed it as a linear combination of x1 and x2 and the multiplication of x1 and x2. Okay, now, because I did that, I should know what the results are. And I do, in fact. Similarly, if I do this, where I model x1 and x2, or if I model y as a function of x1 times x2, look at what happens. So before I had x1 and x2 as main effects. Look at what happens when I drop the main effects in constructing y. Now I only have a significant interaction, and x1 and x2 are non-significant. So what is that telling me? It's telling me that the moderated effect is an exclusive moderating effect. And in fact, x1 alone cannot predict y. x2 alone cannot predict y. It's that the effect of x1 on y is dependent upon the values of x2. Because they're dependent, they are necessary in order to model y. And the omission of moderated effects from these general linear models is essentially equivalent to omitting relevant variables. And if we omit relevant variables, our parameter estimates turn out to be biased. So the failure to include all relevant variables leads to biased parameter estimates. Now, this is not a big assumption that people make a big deal about, primarily because we never have exhaustive models in social and behavioral sciences. However, we do have the ability to estimate moderated effects in everything that we do. So a moderator is simply a logical and. And by specifying a moderated effect, what we're doing is we're exhausting the possible combinations of all possible main effects such that we account for the complexity in our prediction model, and we include possible predictors to exhaust our model. But there's some downside to this that we're going to get to later about statistical power and what have you. So in the next video, I'm going to talk about the hierarchy of testing, of significance testing when you have moderated regression. So stay tuned for the next video.